So this is ELC 131, Circuit Analysis 1, and this lecture, this video, we continue on with our discussion of resistances, but in particular we're going to take a look at potentiometers and variable resistors. Now a potentiometer is a three-terminal device. It's used to control voltage, and this will make more sense as we continue on with our discussions on electricity and in particular series circuits. A variable resistor, however, is a two-terminal device, and it's used to control current. Now, you'll hear the term rheostat, and a rheostat is simply a variable resistor that's used in high-power applications. But a rheostat and a variable resistor are really the same device. Now, we look at a pictorial or a sketch of a potentiometer, and this is somewhat what they look like. The component has three terminals, and I've numbered them or labeled them terminal 1, terminal 2, and terminal 3. And here we see the US schematic symbol for a potentiometer, terminals 1, terminal 2, and terminal 3. Now, the construction of the device is such that existing from terminal 1 to terminal 3 is some fixed amount of resistance. And we'll just say for this example that the resistance of this device is 150 ohms. Now, terminal 2 connects to what's called the wiper. And the wiper just provides us a means of splitting this 150 ohms of resistance into two parts. The resistance could be 0 from 1 to 2 and 150 from 2 to 3. It could be 10 ohms from 1 to 2 and be 140 ohms from 2 to 3. Or it could be 75 ohms from 1 to 2 and 75 ohms from 2 to 3. Let's take a look at the construction of a potentiometer, and this will hopefully make a little more sense. So this shows us a potentiometer that's designed for high power application. This particular potentiometer can dissipate 50 watts of power. And if we look at the backside, well, in here you can actually see the three terminals. This would be terminal 1, this would be terminal 2, and this would be terminal 3. And if we look at the backside of the device, to look at the construction of it, you see that existing from terminal 1 to terminal 3, let me get a little better picture here. This is terminal 1, and this is terminal 3. Existing from terminal 1 to terminal 3 is simply a length of wire wrapped around and around this ceramic core. Terminal 2 right here connects to the wiper, and the wiper can move around and touch that length of wire in different places, therefore dividing that 150 ohms of resistance into pieces. So you see how the wiper is able to move anti-clockwise or clockwise around the length of wire that forms the 150 ohm resistance, therefore dividing the resistance from terminal 1 to terminal 2 and terminal 2 to terminal 3 in any portions of 150 ohms that we want. Now, the application of potentiometers is one that you're familiar with, is for volume control. And if you're a guitar player or a bass player, you're familiar with the idea of using or being able to adjust the tone of the guitar. So the potentiometer is also used for tone control. Now, in the world of electronics, we also use potentiometers to perform calibration of instruments such as meters or instrumentation devices or systems. And in those cases, we use it's a potentiometer, but it has a different name. It's called a trimmer. The trimmer potentiometer is designed to, as we usually say, set it and forget it. Those are not something we're going to be adjusting constantly, such as the volume control or the tone control of a radio or a guitar, but they're used to, again, calibrate the system so that when the meter says it's measuring 1 volt, it is actually measuring 1 volt. So we'll take a look at some trimmers that are commonly used, and this is an example here. And you can see the 3 terminals on the component. Come on, there we go. And then you can see on the end, there's a place where you can use a screwdriver to adjust the potentiometer. Now, here's another type of potentiometer that you may see. And again, you can see the 3 terminals. And looking at the back side, you can see there's a place where we can insert a screwdriver and adjust the potentiometer. And then there's another trimmer pot that's actually got the adjustment point on the top instead of on the end as the first example. So again, the potentiometers that you'll most often use or see for such as controlling the output voltage of a power supply or controlling the volume of a radio or a guitar would look more like this. You can see the 3 terminals. Or they can be trimmer potentiometers used for calibration. Now, when we talk about potentiometers, there's a couple of different types that you may encounter. One's called a linear taper, and the other is called an audio taper. And the audio taper is also called a logarithmic or log taper. Now, what does this mean? Well, with a linear taper potentiometer, if we look graphically at the change in resistance as a percentage of rotation of the shaft of the potentiometer, what that means is there's a linear response. In other words, if I move the shaft of the potentiometer halfway between the 2 limits, the resistance will be half of the resistance from terminal 1 to terminal 3. In other words, that's telling you that we looked at the example of the potentiometer that the wires, as they're wrapped around the ceramic material, those wires are evenly spaced. Now, an audio taper is a little different. The audio taper is designed to meet the needs, we'll say, of the human ear. Now, the human ear functions in a logarithmic fashion. What this means is that the ear is more sensitive to changes in volume with a very quiet sound than it is with very loud sounds. When the volume is very small, the ear is more sensitive to changes in volume. When the volume is very loud, the ear is less sensitive to changes in volume. So the audio taper from half at the 50% point of the rotation, the resistance only changes by about 10%. And then as we go to 100% of the rotation, the resistance goes all the way up to 100%. So at low volumes, we have a large change in the sound volume. At low volumes, we have a large change, and at high volumes, we have, I'm sorry, I said that backwards. At low volumes, we have a small change in the setting of the potentiometer, resulting in a smaller change in the sound volume. At loud volumes, we have a much larger change in resistance. Therefore, we get a greater change in volume. And they do this by changing the spacing of the wires, if we will, the turns of wire on the potentiometer, so they're further apart at the low end and they're closer together at the high end. Now, one other potentiometer that you will probably come across is what's called a multi-turn potentiometer, and the most common one is what's called a 10-turn potentiometer. Excuse me. What that means is, for one turn of the shaft, we only move 10% through 10% of the resistance. And they achieve this by having a gearing system inside the potentiometer. So again, one complete rotation of the shaft only results in a 10% change in the resistance. This allows you much better control for calibration purposes. Now, a rheostat, or a variable resistor, is accomplished by simply using two of the three terminals of the potentiometer. So in our circuit, if we only use terminal 1 and terminal 3, we then have a device that can be adjusted such that the resistance from 1 to 3 is either 0 ohms or the resistance from 1 to 3 is 150 ohms. That's what I mean by a two-terminal device. We're only using two of the terminals. Now, in implementation, what most people do is they connect the wiper back to terminal, oh, I wrote 3 twice, sorry. They connect the wiper back to one of the terminals. Now, this piece of wire shorts out a portion of the winding. We can still achieve from terminal 1 to terminal 3 anywhere from 0 ohms to 150 ohms by moving the wiper's position. Now, the reason we connect the wiper back to terminal 3 is that if the wiper were to hit a dirty place, a place where there's oxidation, or a place where there's dust or dirt or some contaminants, if we did not have this connection, that would put the system in an open circuit condition. No current would flow if we hit some dirty place right here on the wiper. However, by connecting the wiper back to terminal 3, we've always got a path for current through the resistance. So we can never operate the circuit in an open condition or a no current condition. So again, potentiometers and variable resistors. A potentiometer is a 3-terminal device used to control voltage. A variable resistor is a 2-terminal device used to control current. A rheostat is simply a variable resistor that's designed for high power applications.